All right, so the next thing that we want to talk about is Venn diagrams. And the idea behind a Venn diagram is it's a visual representation of the elements of one or more set. So in order for a set to be a well-defined collection of objects, I have to be able to decide whether or not an element belongs in the set, which means that all of the elements in the set have to be a part of a larger grouping, something that we might call a universe. And the larger grouping of the universe might be made up of, let's say, for instance, all whole numbers or all floating point numbers, or going back to the idea of students in this class, maybe the universe is all students at Weber State University, or all students in the state of Utah, or maybe even all students in colleges anywhere on the planet. There is always a universe. And the universe defines the larger grouping that our set is taken out of. A Venn diagram is a visual representation of not only the universe, but our set's place within that universe. So I'm going to draw a square to indicate my universe. I'll even put the letter U on here. And let's say, for instance, that this universe is the set of all students at Weber State University. And then I have a set called A. My set is going to be represented by a circle inside of the universe. And as always, I'm going to give it a capital letter to indicate it. And then I can put the individual elements. And if the universe is the set of all students at Weber State, and my set is A, I'm going to say that I have an element Ann, and an element and Joe, and an element 1. This is my set A. If I were to use normal set notation, I have 3 elements in my set, Ann, Joe, and 1. These are the elements in my set. A Venn diagram is just a visual representation of that set A as it's placed within the universe. Now there are tons and tons of other students. We have Stephen and Mary and James. There's a bunch of other students that are not students in our class, that are not students in, my set A. And so my Venn diagram, I have the universe, and then I have my set A. We can also have a second set, other sets. Let's say that this is set B. And so this is going to be Tom, and we'll have Manuel, and then we'll have Kim. So I have a second set B with another set of students that are taken out of that universe. And the Venn diagram is a visual representation of one or more sets in the universe. One of the benefits of the Venn diagram is that just by looking at the sets, I should be able to tell if there are common elements between the sets. So I'm going to come down here and I'm going to draw another universe. This time, my universe is going to be made up, just to make it easier, my universe is going to be made up of integers, whole numbers. And so I'm going to have a set A. And A is going to contain the numbers 1, 2, 3, and 4. And then I'm going to have a second set. If I were to draw it, A is the set 1, 2, 3, and 4. I'm going to have a second set B that is also part of this universe, which means it's going to be contained with integers. And this time it's going to contain 6, 7, 3, and 50. Now just by looking at these two in set notation, I might not be able to tell if there are common elements. But in a Venn diagram, I'm going to draw the second one, and this is set B. And if you'll notice, there's also a 3 in set B. There was a 3 in set A and a 3 in set B. And then it also has 6, 7, and 50. And if this is all integers, there are obviously a lot of other elements or numbers in the universe that are not made up of either set A or set B. And by looking at my Venn diagram, I can quickly and easily tell that 3 is a common element between sets A and B. If I look back to my original set, I can tell automatically that there are no common elements between A and B. So a Venn diagram is a visual representation of one or more sets. And just by looking at it visually, I can tell a lot of properties of 2 or more sets. For instance, without even knowing what are in the sets, if I say this is my universe and I have some set A and I also have some set B. Without even knowing what the elements are, I can visually tell that B is a subset of A, because B is wholly contained within A. As a side note, I cannot tell whether or not A is a subset of B, because I don't know if there are elements that are outside of B that are contained in A. If it had shown me an element here and then an element here, now I know that A is not a subset of B because there's an element outside of B that is contained in A. But I still know that B is indeed a subset, and it's actually a proper subset of A. And a proper subset means that the subset is smaller than the superset, that there is a value contained in A that is not contained in B. And so it is proper that the subset would be smaller than the superset. That seems only proper. One final thing that I would point out is in my original set A and B of students in this university and students in the class, this is actually called disjoint. And that is a property that just means that there are no shared elements between the sets. So A and B are disjoint sets because there are no common elements. When I look at my second set in the universe of all integers, A and B are not disjoint because they share a common element 3. And then my final set at the bottom is also not disjoint because B is a subset of A, which means they have to share common elements.